Good morning, welcome to Stats. Just a quick announcement. If you did not come to conferences, I want you to be aware that something that you can do to study for the cumulative, which will come up after the Unit 4 test, is to go to the AP Stats topics. And in the topics, I've added something to general resources, in particular, the scripts and the script answers. So I would recommend that before you take the quiz, or before you take the next cumulative, or maybe every day from now until the cumulative, go through the scripts, quiz yourself on scripts 1 through 21. We have not yet hit statistically significant 22. So scripts 1 through 21, like on the last test, some of you forgot the interpretation of R squared. And then, in case you're wondering what those are, we've got the script answers there also. So you can check to make sure you know what's going on with the scripts so far. Also, in the Unit 4 topic, I'll be making this practice quiz available. Those of you who are present today already have a copy of the practice quiz. Please read over this so that as you're doing what I want you to do for Monday of next week, which is to read Chapter 12. We're in Unit 4 right now, which is Chapter 12 of the book. Be asking yourself, am I learning from Chapter 12 what's going to be required on next Wednesday's quiz, which is very similar to this practice quiz? By the way, the reason I'm asking you to read Chapter 12 is because this chapter is by far the most vocabulary intensive chapter in the entire 27 chapter course. The vocabulary for sampling strategies and types of bias are nuanced, and so it's best that you read the book. So let's jump into where we left off on the lesson from Wednesday. We're on number 5. We're in the 5.1 lesson. Gallup, at its website, gallup.com, the Gallup poll publishes results of a new survey each day. Scroll down to the end, you'll find a statement that includes words such as these. Based on the results of a telephone interviews with 1,008 national adults aged 18 and older conducted 2 through 7 2000. In addition to sampling error, okay, so that's an important vocabulary term. Sampling error. Question wording and practical difficulties in conducting surveys can introduce error or bias into the findings of public opinion polls. There's nothing wrong with sampling error. Sampling error is to be expected. So, question here is for this survey, identify the population of interest. We drew the 3 circles last time. We had the population circle, the sampling frame circle, and then the sample circle. They want to know what's the population of interest. And essentially, suppose they ask them, who are you going to vote for? If the 2020 election was held today, would you vote for Donald Trump? And they're trying to find the true proportion P. What is it? 52% would vote for Trump, 48%? What is it? So we use these P hats from the sample proportions from the sample in order to approximate what's going on in the population. So the blue P hat value, which comes from the sample, enables us to estimate something about the population. Well, the population of interest is indicated by the word national. It's not Wisconsin adults. It's not DuPage County adults. It's national adults. That's the indication that the population of interest is all adults in the United States, age 18 and older. So we want our sample to be representative of our population. You won't be able to judge whether your sample is representative unless you know what the population of interest is. You want blue to be representative of red. Part B, Gallup performs its surveys by phoning numbers generated at random by a computer program. What's a sampling frame? Well, that's way better than having a sampling frame and being the phone book, because whose phone number is in the phone book anymore? Nobody's number is in the phone book. You don't have your cell phone number in the phone book. Back when I was a kid, it had my address. I lived at 1191. I should say on the internet what my Because he's going up on YouTube, so I shouldn't say what my childhood address would be. That could be some sort of key answer to a security question. But it did have, it had my address, my parents' names, phone number. I still remember what my phone number was for our landline when I was a kid. Here's code 414. Okay, but they didn't use a phone book. Their sampling frame was numbers generated at random by a computer program. They might have programmed it to say, to pick only the area codes that actually exist in the United States. That's a pretty good way to get a representative sample. Now, it's only for people with phones, so the difference between the sampling frame and the population is people who do not have phones. But these days, a lot of people have phones. I don't know if you've been, waking up every day, if you're woke enough to figure that out. But so what's a sampling frame? The sampling frame is U.S. adults with, cross off landline. It's not landline anymore, with telephones. Because it's computer generated, it can even snag cell phones. So U.S. adults with telephones. Now, what problems, if any, would you be concerned about in matching the sampling frame with the population? I mean, hopefully, when you're designing a survey, you want the sampling frame to match the population as much as possible. You don't want there to be this huge gap. But there are some potential problems. Some members of the population, for example, this is from the 3rd edition of our textbook. Wow, things have changed a lot. Because in the 3rd edition of our textbook, this is the current edition. Actually, the 4th edition has come out, but we haven't updated to the 4th edition yet. Back in the 3rd edition, it was like, oh, I'm in college, I don't have a phone yet. So let's cross off for example, now, guess what? College students have phones. That whole objection. So it's not some members of the population, for example, it's some members of the population, and you have to cross off, let's not. So let's say people without phones. Would it be embarrassing to say, well, maybe like homeless people? Well, who am I to say that homeless people don't have phones? Maybe they say, well, I'm not gonna have a home. I'm gonna have a phone. So we can't assume that homeless people do not have phones. Who is it that doesn't have phones? I don't know. I don't know if you can describe general characteristics of the population of people who do not have phones. Maybe some people have religious objections to being on the grid. I just don't know how to describe them. So let's just say some members of the population don't have telephones, so they could never be chosen. So that may create a bias. It could be that these people who don't have phones have completely different views about who to vote for in the next presidential election. Yes, go ahead, Lewis.
Isn't letter A and letter B kind of the same? Because letter A, you're talking about the population who could vote, and then your sample frame is like people who have phones. Isn't like that kind of?
It's possible to vote without a phone. There are people with no phones who can vote. They can register to vote without a phone, and they can vote without a phone.
So sample frame is how we collect data.
That's right. It's like the database from which we will collect our SRS, our simple random sample, or maybe our stratified sample. Okay. All right. So let's keep going here. Learning targets. Okay. So now let's go to problems 7 through 14. For the following reports about statistical studies, identify the following items if possible. What is, for this study, what's the population parameter of interest, the sampling frame, the sampling method, and any potential sources of bias. Now, in terms of vocabulary, this is why I'm having you read chapter 12 to really internalize this, but the population parameter of interest. I mean, the word parameter, it doesn't even come up in calculus, AP Calculus AB. You don't really have to study parametric equations in calculus until you get to calculus BC. Of course, they put parametric equations into advanced pre-calculus so that you'll be ready for Calc BC. But the word, and for me, I was a math major, we did parametric equations. I didn't really understand parameters and parametric equations until I got my hand on a graphing calculator for the first time back in 1988, I think it was, maybe 87. 87, 88 was the first, that was the invention of the graphing calculator. Not exactly a pivotal moment in the development of Western civilization, but it certainly got my attention. It's like, wow, now I finally understand parametric equations. But the parameter used more generally, for the purposes of AP Stats, there's only two that we look at. There's only two parameters, P and mu. Sigma is technically a parameter, but we don't do studies to try to find the true standard deviation. We do studies to try to find the true proportion of people are going to vote, let's say, for whoever it is, or what's the mean? What is the true mean? So these are the only parameters you really need to care about. A parameter, in the context of AP Stats, is a characteristic of a population. Parameter goes with population. So we talk about parameters of the population. And then we talk about statistics of the sample. So we're going to go a different color here. I think that green, will not make a big deal about the color coding, but we talk about statistics of the sample. So P with P, S with S. Parameters relate to or describe the population. Statistics describe the sample. The statistics would be P hat. That means sample proportion, not predicted proportion. Hat means predicted in the context of linear regression. But here, hat means sample. Sample proportion, X bar means sample mean. So P hat and X bar are statistics which we harvest from our sample that hopefully is obtained using a sampling strategy that is free from bias. But we use these statistics to estimate the true parameters of the population. Statistics come from the sample. Parameters describe the population. When I say go, I'd like all of you to say out loud and in unison, statistics come from the sample. Parameters describe the population. Ready? Go. Statistics come from the sample. Parameters describe the population. So, what is the population? What's the population parameter? It'll be either P or mu, okay? So that's always a two-part multiple choice question. Which is it? The proportion of something in the population or the mean of something in the population? What's a sampling frame? What's a sample? What's a sampling method, including whether or not randomization was employed, and what are potential sources of bias? So, let's take a look at number 7. The Consumers Union asked all subscribers, well, you got to read carefully, they asked their subscribers, whether they had used alternative medical treatments, like acupuncture, stuff like that. And if so, did you benefit from poking yourself with needles? For almost all of the treatments, approximately 20% of those responding reported cures or substantial improvement in their condition. Okay, what happened? Oh, I got cured. Approximately 20%. Oh, by the way, what is 20%? Is that a P or a P hat? It came from the sample. It's not the truth. You don't know the truth. No one but God knows the true proportion of people who benefit from these alternative treatments. I know, maybe most of you are into these alternative medical treatments. So
are you not?
I'm just not going to disclose whether I poke myself with needles. But, so I'll just have to leave that to your conclusions. So 20% is not P. 20% is P hat. We're going to use P hat to approximate the true proportion. That's what we're after. We're after the true. It's like people have questions. I don't know if you're aware of this, but the scientific method always starts with a question. Here the question is, I wonder what proportion of people actually benefit, or at least report that they benefit from alternative medical treatments. Okay. That's, if you want to poke yourself with needles, maybe that's the way to go. I'm not going to tell you not to. Okay, so the population is, it doesn't say United States up here, so it's like, well, Consumers Union, this is a book published in the United States. It's about United States examples, unless they say otherwise. So these are some of the assumptions we have to make as we're all U.S. adults. We don't care what the kids are doing. So what are the adults doing? We're not going to survey kids. Parameter. The parameter is this. It's either mean or proportion. When you're answering the question about the population parameter of interest, you're going to say either the proportion who have done something or the mean of something. This time it's a proportion who have used and benefited from alternative medicine. Is this already written down for you? Wonderful. So this is just the example thing. And then you're going to get to do one on your own. Here's where I get to explain what's going on. How about the sampling frame? It's not the same as last time. It's not people who have phones. This time the sampling frame is people who actually subscribe. It's like, oh, that's convenient. We say it's convenience bias. Well, maybe it's a little bit. No, could be undercoverage due to poor sampling frame. Because people who subscribe to Consumers Union may or may not be representative. I don't know, that's a question. I'm not saying the subscribers to Consumers Union are not representative of the population of US adults, but that's a question we have to ask as survey engineers. The sample is those subscribers who actually responded. It's the ones who respond, not the ones who are selected. Not the 50 who are selected, it's the 40. And the method was not specified. They didn't tell us, was it simple random sample? But you know what they did? They probably mailed a questionnaire to everyone. And then people just volunteered to respond. Some people responded. They didn't say they were selected randomly. So notice we have to read between the lines on some of these. The bias. Okay, this is the hardest part. What's the bias? There's a lot of different types of bias we learned about. And we're zeroing in. I mean, there's always going to be non-response, but it's voluntary response bias. They asked for volunteers, basically. They said, please respond. They didn't say you have been randomly selected. It's really important to respond. And if you don't respond, we're going to send someone to your door and say, please respond to our survey. Because it's really important. You're part of science. And if science is, what, do you want to be responsible for stopping the progress of science? That's what the person at the door is going to say to you. They're going to get in your face. No, that's just say, hey, please take our survey. Most people throw it away. So here, you try one. Why do these chips taste funny? Do you lick these chips? Something's wrong with them. A company packaging snack foods maintains quality control by randomly selecting 10 cases from each day's production and weighing the bags. Wonder why they're weighing the bag. Then they open one bag from each case and D is missing and inspect the contents. Okay, so see if you can identify all of these. What's population? I'm going to pause the camera while you're trying to fill in the answers to this, and we'll talk about it. We're back, so let's talk about these. We have a population. Now, there's actually something missing here. This is a little bit lame. It should say all snack food bags in the entire universe? No, only the snack food bags in the Milky Way galaxy. No, that's not it either. Only those in America. No, it's all snack food bags produced at this company. Be specific on next Wednesday's quiz. I'm going to read carefully to ask myself, where would I draw the circle that represents the population? Is it just around the snack food bags produced by this company? Is it all snack food bags produced in the United States? All snack food bags that were produced between the years 1901 and 1910 AD? Or, between 3 and 4 BC, which, be specific so I know where to draw the circle that represents the population. So, And it's probably, they don't even really care probably about all of them over what time frame. Could be this year. Well, they didn't put all that in there. So we'll just say, you know what, they probably do care. The company cares about all their snack food bags and their quality. The parameter is the proportion passing inspection. But I think we can do better than that, because what do? They weighed them. So they're probably inspecting to see if they actually meet the weight. Like, this is Chobani yogurt. It says 32 ounces. The reason they're weighing it is probably to make sure that the weight matches what they say it says 2 pounds. Let's weigh it to see if it, we'll inspect them to see they have the correct weight. So when they say parameter, this is what's written here is kind of lame because it doesn't include the word mean or the word proportion. So what proportion passes inspection? See, and since they're weighing, you might be thinking, well, maybe they're looking for the mean weight. Or maybe so you have to put yourself in the shoes of the person collecting data and the person designing the survey and say, well, what are they interested in? Why would they be weighing every single snack bag? Well, yeah, they might be looking for the mean weight, but actually they probably care about what percent of them are underfilled. So proportion passing inspection, which is basically, it's a P. What's the true proportion that weigh the advertised weight or higher? Or maybe it could be what's the proportion that don't pass inspection? But you have to write down something reasonable there. It's a proportion, probably not a mean. They probably don't care about the mean. But notice how it's, in this case, you could make a case for, well, maybe they're weighing them because they want the mean weight. So pick one and give your reason. Sampling frame is from each day's. Okay. So the sampling frame is all of the bags that are produced by this company in one day, because the word daily, they did tell you the sampling frame is, take a look at those. The sample is, well, they tell you what the sample is too. Yeah, it's 10 bags. The sample is 10 bags because they told you they took one bag from each case. The method is multi-stage sampling. It's presumably SRS for stage 1 and SRS for stage 2. They did a simple random sample of 10 cases. And even though it doesn't say they randomly selected one bag, it's something to say, well, look, if they're using randomization here, they're probably using randomization on selecting the bag. I mean, come on, this is a company, they're trying to be professional. There's no indication of bias here. This actually looks like a solid approach to sampling. They're using randomization. The history of randomization in science is actually both fascinating and sad. Do you know the name of the person who first realized that in order to get good samples that represent the population, we should use randomization?
What's his last name, randomization?
No, it was Charles Sanders Peirce. It looks like Pierce when it's written down, but it's pronounced Peirce. His dad was a professor of math at Harvard University, and he wanted to be a professor at Harvard also, but they wouldn't accept him because of his relationships with women outside of marriage. So he ended up having to teach at Johns Hopkins University, where they had different standards. Back then, in the 1800s, at Harvard, if you were messing around sexually, they said, sorry, you don't have the moral character to teach at our institution. So, but he had this incredible insight that if we're going to get a representative sample, we should use randomization. And that was the late 1800s. Scientific sampling as part of the scientific method is recent. Less than 200 years old. And it's thanks to Charles Sanders Peirce, who died in poverty struggled just to get enough firewood to keep his cabin warm in Ohio. Lost a lot of his friends. So it's more to life than just being super good at math and science. It's also good to pay attention to your relationships. That's a lesson that we can learn from Charles Sanders Peirce, the guy who realized that it's randomization that can eliminate bias. So thank you, Dr. Peirce. Now, let's go on to the next handout. The next handout, sample surveys part 2. Okay, let's take a look at this mistaken poll. Go ahead and read through that first example. Let's talk about it. Actually, you can read with me. It says a local TV station conducted a pulse poll about the upcoming mayoral election. And again, I just want to emphasize that this book from which this is taken, Bach, Velleman, and DeVoe published this book. First edition came out 2004. So this problem was written 2004. Based on phone calls, the station predicted that Amabo would win the election with 52% of the vote. Is that a P or a P hat? Class?
P hat.
It's a P hat. It's a sample proportion. We want to know the true proportion. They were wrong. Amabo lost. I'd been teaching this course for 5 years before a student said, wait, Amabo, that's Obama spelled backwards. This was written in 2004. What year did Barack Obama become president? 2008. What?
Wait, who wrote this?
Bach, Velleman, and DeVoe in 2004. Now, they were wrong. Amabo actually lost, getting only 46. So what's 46%? 46 is P. That's the true proportion. So they were using P hat to approximate P. There was error. Of course there's going to be error. The question is, was there bias? There's always going to be error. Error is okay. Error and bias is bad. Was this error the result of bias or sampling error? Well, the station's faulty prediction is more likely to be the result of bias. There's something bad here called bias. Only the people watching the news were able to respond. So the sampling frame was people watching the news. And their opinions were likely to be different from those of other voters. These days, people don't watch the news anymore. They don't even watch the news. What's news? Who watches the news? They just go to some website. But back then, this is what life was like for me as a kid. When I was a kid, we'd watch the news as a family twice a day. Which is going to be interesting to my dad, because my dad watches all these YouTube videos that I post. And so, yeah, Dad, I remember, after dinner, right after dinner, we'd watch the news. We'd watch the 6 p.m. news, sometimes the 5 p.m. news and the 6 p.m. news. And then we would gather again as a family at 10 p.m. to watch the 10 o'clock news.
There was different news 4 hours apart?
Yeah, well, they would have sometimes an extended weather and sports section. There's always news, weather, sport. First 10 minutes was news, second 10 minutes was weather, 10 minutes of watching the weather together as a family, and then 10 minutes of sports, because there might have been some sports events that happened that evening. So it was always fun to watch. Loved it. Now, so it's only people watching the news. Imagine me and my dad, my mom and my brothers and sisters sitting around the TV watching the news. They're able to respond. Their opinions were like, see, not everyone did that. Some people don't sit around watching the news. You have to have a television, you have to have a house. In most cases, a sampling method may have systematically produced samples that did not represent the population of interest.
Why systematic?
Yeah, as I was pronouncing that word, I was wondering the same thing, because that sounds like, when you see systematic, we had that definition just last time we met about systematic approach to sampling. A systematic sample is where you say, let's take every third case of potato chips, or every 300th case of potato chips. Yeah, so that's, so I'll tell you what, sampling method may have, let's just cross off the word systematically, because we don't need it, and it's distracting. It doesn't help us. It may have produced samples that did not represent. That's the point. The point is that your sample should be representative of the population, and this one probably was not. Now, let's illustrate this with the targets. And on these targets, I want to This is like a big deal. The reason I put this color handout together for you is I want to show you what it looks like to have no bias and no sampling error, no bias and yes sampling error. This is all to illustrate that bias is bad. And by the way, since there are a few people absent, I'm going to post all the handouts for Unit 4 on the in the Unit 4 topic so that people who are absent can take notes from this. Should be up by 4 p.m. Friday. 4 p.m. today. Friday, October 26th, I'll have the handouts posted. Okay, so there's 4 things I'd like you to see. What would no bias look like? Well, suppose you're hitting a target. This is a metaphor. We're using the target metaphor. But if you're taking a bow and arrow, standing 50 yards away, and if your shooting is unbiased, then, you know, sometimes you might hit the target. I want to make these yellow so you can really see them. Sometimes you hit the target, sometimes not. But notice that the average of all of your arrows that you're shooting at the target, the average is the bullseye. Means it's unbiased. It's unbiased. There is sampling error. If there were no bias and no sampling error, do you realize that what this would look like? In the bullseye, every single arrow would bullseye. That's no bias because it's accurate. And there's no sampling error, meaning that it's perfect precision. So accuracy and precision are what are being measured by bias and sampling error. So draw a little picture of what no bias and no sampling error would look like. It would be like every survey hitting 46% Amabo, 46% Amabo. Next survey, 46% Amabo. No bias and no sampling error. Usually with surveys you get sampling error in that this every survey is a little bit off of the 46%, but when you average them together you get 46%. Yes, go ahead.
And that's ideal, but is it really possible?
No. That's no one's shooting for that because they know it's not reasonable that every survey would hit the true proportion right on the bullseye. So this is a 2-dimensional analogy for something that's usually handled in 1 dimension, that is averaging all the p-hats. But 2 dimensions makes a little more sense. Now, what if you had bias and sampling error? If you had bias and sampling error in this metaphor, you would hit the target and the average of all of your arrows would be something other than the bullseye. This is what bias with sampling error would be. Can you draw a picture of what you think I'm going to draw for situations where you have bias but no sampling error? What would that look like? What would the pattern of arrows hitting the target be? Go ahead and draw it. Draw what you think bias, if this is the bullseye, this is the center circle. What would a situation where you have bias but no sampling error whatsoever? Center circle. And when you're done, can someone describe what it would look like to have bias but no sampling error whatsoever? Andrew.
They all hit at a spot of your choice.
Every single arrow hits somewhere that is not the bullseye, a spot of your choice. Yeah, that's a visual reminder of what we mean where it's saying, well, yeah, we have bias, but there's no sampling error. Okay, come on, you're always going to have sampling error in the real world. Only theoretically could you have no sampling error. Any questions on our first example about Amabo, who never became mayor? All right, let's keep going then. It's fun so far. I'm having fun. Parent opinion. Survey the parents. So what are we going to ask the parents? In a large city school system with 20 elementary schools, the school board's considering the adoption of a new policy. Tell you what, I'm looking at the clock. We don't have much time left, and this is an important example. So I'm going to hit the camera. Just remember, read chapter 12 for Monday.